Prathamesh, am I audible to you? Just type the comment whether am I audible. Okay, okay, thank you. Okay, I think we should start now. So we are discussing here the numericals on die design. So here you can see the statements of the numerical, that is design, draw a compound or progressive die for the blank as shown in following figure. Show all the calculation required for this operation. The figure will be given, that is the components, shape of the components which we required there, and accordingly the material will be also given in the numerical. Then you can find that is the thickness is also given, then ultimate shear strength, so that is also given there. So what you have to do, that you have to design the die for cutting these particular components. So here the first procedure, that is nothing but you have to select a press, that is that is simple, compound and progressive type of dies are there. So one of the dies you have to select there. So here in the numerical itself it is mentioned, that is compound or the progressive die you have to use there. So if you look towards the component which you want to manufacture, so it is unsymmetrical, and that's why what you have to do, first of all you have to calculate the center of pressure of this particular component. So what is center of pressure? So basically when the shape of the blank to be cut is irregular, the summation of shear forces about the center line of the press ram may not be symmetrical, and due to this bending moment will be introduced in the press ram, producing misalignment and undesirable deflection. So to avoid this, basically the center of pressure of the shearing option of the die must be found out, and while laying out the punch position on the punch holder, it should be ensured that the center line of the press ram passes exactly through the center of press of the blank, and this center of pressure is basically the centroid of the line perimeter of the blank. It should be noted that it is not the centroid of the area of the blank, but it is the centroid of the line perimeter of the blank. So from the numerical, as far as the components which you want to manufacture, so cannot be manufactured there on the simple die. So here we can select a progressive die. So first step for designing this particular numerical. So that is nothing but the selection of the press. So here the progressive die of two stations, so that can be selected, that can be used where tolerances are not tied there. And so that is the first step, that is the selection of press. So next step, that is we have to calculate the center of pressure. So for calculating the center of pressure, so again there is the procedure. So this particular PDF, so that already I have shared with you. So there is a procedure. So first step, that is draw the outline of the cutting edges. Then next step, that is draw axis of xx yy in the convenient position. Then next step, that is find length, that is L1 to L6 of each elements. Then find CG of each elements on x axis and y axis. So first of all, whatever the component is there, this one, so this particular component will be divided into line segments according to the outlines on which basically the cutting is required to be done there. And so first of all, you can see here the axis will be marked. So here you can see this one is the y axis, this one is nothing but the x axis. So accordingly axis will be marked there. So that is the first step, that is the draw outline of actual cutting edges. Next step, that is axis will be drawn, that is xx and yy axis, yy in convenient position. Then you are going to number the line segment, and so you can see this one is the first line segment, then this one is nothing but the second, then you can see this line segment is nothing but the third one, this one is nothing but the fourth line segment, then you can see this one is nothing but the fifth line segment, and whatever this circle is there, so that circle is nothing but the sixth line segment which is there. Okay, so this total geometry will be divided into line segment. So 6 line segment, so wherein 5 lines are nothing but the straight line, and 6 elements, and a line, instead of line segment we can say 6 element, and so that sixth one is nothing but the circle. Okay, so there are the 6 total elements. So you have to calculate the center of pressure of these particular elements. So here you can see the table, that is there will be the element will be mentioned, that is element 1 to 6. Then length of those elements will be calculated. Length of those elements will be calculated, so that you can see length of first element. So this one is the first element, this one. So length of this, that you can see, that is 20 mm. So here 20 mm is mentioned. Then second element, so this one is the second element. So I will rub the previous marking. Okay, so this one is the second element. You can see the length is 20 mm. Then third element, this one is nothing but the third element. So to calculate the length of this third element, so what you have to do, you have to extend this one and consider this particular right angle triangle. So apply the Pythagoras theorem and calculate the length of third element. Okay, very simple. Then fourth elements, so for that particular purpose again, how we can calculate the length of fourth element? So again you have to consider this particular right angle triangle, and by using Pythagoras theorem, so you can calculate the length of this particular fourth element. Okay, so am I audible now clearly? Just comment. Yes, just reply. Am I audible or not? Okay, okay. Thank you. So I will request all of you to give the feedback whether I am audible or not, and in the chat box, please. Please give the feedback in the chat box. Am I audible or not? Please, everybody. Okay, thank you. So here length of these different elements, so that will be calculated. And so here we can see length of third element, then fourth element, so that is calculated by considering the right angle triangle. So it is 14.142 the length of third element, and it is same as per as the fourth element which is concerned. Then fifth one, so this one is the fifth element, so that you can see. So directly you can write the length of that, it is 20 mm. Then sixth element, so this sixth element is nothing but the circle. Okay, so length of this particular circle, so it is nothing but the perimeter of that particular circle. So perimeter is nothing but equals to pi d, or you can say 2 pi r. So accordingly the radius of this particular circle, so that is known. So from that you can calculate the length of this particular element, that is the circle, that is the element number 6. Okay, so it is clear to you now. So very simple, in this way we can calculate the length of each element. The next thing what you have to calculate, so that is nothing but the x we have to calculate. So what is x? So x is nothing but equals to the distance of that particular element, or we can say distance of that particular elements, or the centroid of that particular line perimeter, distance of that particular element centroid from the y-axis. And so when we say x, so it is the distance from y-axis, and when we say y, so it is nothing but the distance from x-axis. Okay, so this you have to remember, that is x is nothing but the distance from y-axis, and y is nothing but the distance from x-axis. So consider the elements number first, this one. So what is x as far as this element number 1 is concerned? So it is nothing but the distance from y, so that is nothing but the x. So basically you can see that element number 1 is lying itself on y-axis. Okay, so element number 1 is lying itself on y-axis. So what is the distance of this particular element from the y? So it is 0. Okay, are you getting this? Just comment, Are you getting this? X is nothing but the distance from Y, and as far as the element number 1 is concerned, so it is lying there on the Y axis. So what is the distance of this particular element number 1 from the Y? So it is 0. Okay, and on that particular element itself, somewhere the centroid will be lying. So what is center of pressure here? So it is the centroid of the line perimeter, and not the centroid of the area, but it is the centroid of the line perimeter. Okay, so as far as this element number first is concerned, so it is lying there on the Y axis. So what is X? So here X is nothing but equals to 0. Then consider the next one, that is second element, this one. So here you can find the total length of this particular second element, and centroid will be somewhere at the center. Okay, so what is the distance of this particular element to centroid from the Y axis? And so that is nothing but the X. That is nothing but the X. So what is the length of this particular second element? So it is 20. So centroid will be here at the center. So what is this particular distance? What is this particular distance? So it is the total length of that particular element, that is second, element number second, divided by 2. So total length of this particular element is 20 divided by 2, so it is 10. Okay, so it is nothing but equals to 10, and our total length is 20 divided by 2, so it is 10. And what is X? That is, X is nothing but the distance from Y. Okay, then go to the next element, that is element number third, this one, element number third, this one. So as far as the element number third is concerned, so where will be the centroid? So here you can see third element, this one. So centroid will be somewhere at the center like this. So basically you have to calculate what is this distance, that is the distance from Y. Okay, so here we know this particular distance, and this particular distance we know this is nothing but equals to 20, and centroid will be somewhere at the center, and here you can see the centroid will be somewhere, centroid of this particular line perimeter, that is element number third, will be somewhere at the center. So what is this total distance? And which distance I am talking about? This one, this distance. And so this total distance is nothing but 10. Okay, this total distance is nothing but 10, and this distance is nothing but 20. So 20 plus 10 divided by 2. Okay, 20 plus 10 divided by 2. So it is nothing but 20 plus 10 divided by 2 is 20 plus 5, that is 25. Okay, are you getting this? Very simple. X is nothing but equals to distance from Y, and Y is nothing but equals to the distance from X. So take the centroid of that particular element, and centroid of that particular element, that is the total length of that particular element divided by 2, and take that particular straight distance, and so that will be the centroid of that particular line perimeter. Okay, so in the same way you can calculate the distance X as far as the element number 4 is concerned. Distance X, so that you can calculate as far as the element number 4 is concerned. So again it is the same, so it is lying somewhere else here at the center. And what is this particular distance? So it is the distance this much this much distance plus this total distance, and which total distance, this one, and this total distance divided by 2, divided by 2, so that is 20 plus 10 by 2 is 25. Okay, are you getting this or not? And let me know, and please comment on the chat box. So if you are getting, type getting. If not, I will repeat the same. And please comment. Let me know whether you are understanding this or not. Because whatever the geometry, the procedure for calculating the center of pressure is going to remain same. So in the same way, you have to calculate the center of pressure. Yes, please comment. Okay. So go to the next element, that is element number 5. So you can see here which one is the element number 5, this one. So we have to calculate the center of pressure of this element number 5. So what is the total length of this element is 20. So center of pressure will be somewhere here, that is in the middle. So total length here is the 20 divided by 2. So this distance is nothing but the 20 divided by 2, so that is 10. Okay. So as far as this element number 5 is concerned, so what is x here? That is 10. Then consider the element number 6, that is the circle. So again, if you look towards the circle, element number 6, so you can see the centroid will be somewhere at the center. Centroid will be, that is the center of pressure will be somewhere at the center. Means this distance you must have to calculate. So what is this distance? Now this particular distance you have to calculate. This one. So you know this distance is, again it is 10, and again it is 10. So x is again, that is as far as the 6 is the element number 6 is concerned, so it is 10. Then next we have to calculate, that is y. So what is y? So y is nothing but again the distance from x, distance of that particular element, or the distance of centroid of that particular element from x-axis. Okay, distance of centroid of that particular element from x-axis, so that is nothing but the y. So consider the first element again, this one. So what is y? That is the distance of centroid of this particular element from x. So what is the distance of centroid of this particular element from x? So you can see here, this is what is the distance, that is y. So what is this total length? It it is 10. So 10 divided by 2, not 10, that is 20. So 20 divided by 2, so it is 10. Okay. Then consider the next element, that is element number second, this one. So what is the where the centroid will be there as far as this second element concerned? So it will lie on this particular line. So what is the distance of this particular centroid from the x-axis? So this is the total. This is the distance. So how much it is? So it is 20. Okay. So that distance is nothing but 20. Okay. Then consider the element number third. So consider the element number third. So here element number third. So this is the element number third. So where the centroid, that is the y, so it will be at the center somewhere else. Okay. So for that particular purpose, again you have to calculate this particular distance. So what is this particular distance? So we know this distance, that is equals to 10. So 10 plus this distance, and so it is 5. So here you can say that is y is nothing but equals to, that is distance from centroid of this particular element, centroid of this line perimeter of element number third from the x-axis. So that is 50. Okay. Are you getting this or not? And now let me know, please. And if you are understanding this, please tell me whether you are understanding or not. Please comment in the chat box. Okay, thank you. And so here element number, we have calculated the y as far as this element number third is concerned. So next one, that is element number fourth. So centroid of this particular fourth element will be somewhere else, that is in the middle. So this distance we have to calculate, and this distance we have to calculate there. So we know this particular center distance, this one, this distance we know, that is 10. So this distance, the centroid of this element 4 is nothing but, we can say this distance we know, that is 10. So 10 divided by 2, so it is 5. And so this distance is nothing but equals to 5. That is distance from x, so that is nothing but the y. Distance from x, so that is nothing but the y. Okay. So once again I will repeat as far as the fourth element is concerned. So here this one is the fourth element. So centroid will be somewhere at the center. And so what is center of pressure? So it is not the centroid of area of that particular element, but it is the centroid of the line perimeter of that particular element. So here centroid will be at the center here. So this distance, that is nothing but the y, that is the distance from x. So that you have to calculate. So we know this particular distance, that is nothing but equals to 10. So 10 divided by 2, so will be the this distance, will be the this distance, and that is the 5. Okay. So go to the next element. to the next element. So which one is the next element? So next element, so that is nothing but the element 5, element number 5. And so this line, and this line segment, and that is element number 5. Okay. So what is the distance of this particular element 5 from the x-axis? Centroid of this particular element 5 from the x-axis. So it is, you can see it is lying there on the x-axis. So centroid of this particular element 5 will be on the somewhere on this particular line. So basically it is lying there on the x-axis. So that's why what is the distance of this particular element 5 or the centroid of this element 5 from the x-axis? So it is 0. So once again I am repeating, what is y? So y is nothing but the centroid of that particular element from x-axis. Centroid of that particular element from the x-axis. Centroid of that element or centroid of that particular line perimeter or whatever that particular element from the x-axis. So that is nothing but the y. So here this particular element is lying there on the x-axis itself. So what is the distance? What is y here? Distance from x. So how much it is? So it is lying there on the x-axis. So it is equals to 0. So very simple. So are you getting this? Now let me know. Have you understood this? Why? As far as the element number 5 is concerned. Now please comment. So have you got this? Very simple. So what is y? That is distance from x. And what is x? That is distance from y. Okay. So please comment. Have you understood this for element number 5? How it is 0? And just comment on the chat box. Just comment in the chat box. No. Okay, once again I will repeat. And Suresh is saying no. Okay. So listen once again. And first of all, remember what is x. And we are calculating the center of pressure. And means x we have to calculate and y we have to calculate. And so we are considering the element number 5. This one is the element number 5. This one is the line perimeter. This one. Okay. So what is x? That is the distance from y. Distance of that particular element or distance of centroid of that particular element from y-axis. So that is the x. And what is y? Y is nothing but the distance of centroid of that particular element from x-axis. And so when we say y, so it is the distance of centroid of that particular element from x. And when we say x, that is the distance of centroid of that particular element from y. Okay. So go consider this one, that is element number 5, this one. So what is the centroid, where the centroid of this particular element will lie? So basically it will lie on this particular element, a particular line, this one, and this line. So somewhere here, so it will lie there. So what is the distance of centroid of this particular element 5 from the x-axis? So if we look towards the element number 5, so it is lying there on the x-axis, and on that particular x-axis itself the centroid of this particular elements will be there. So what is the distance of centroid of this particular element 5 from the x-axis? How much it is? So it is 0. because it is lying there on the x-axis. That is what is y. Okay, have you understood this? Please comment. And how it is 0? Yes, Suresh. Okay, thank you. And so very simple. Just remember, x is nothing but distance from y-axis, and y is nothing but the distance from x-axis. And we are going to consider the centroid of the line perimeter. Okay. So once you have calculated the length, and once you have calculated the x and y, the next parameter we have to calculate, that is nothing but Lx. What you have to calculate next? That is Lx. So what is Lx? That is L multiplied by distance x. And so for element number 1, what is L? That is 20. What is x? So it is 0. So obviously Lx, that is the multiplication, L multiplied by x will be equals to 0. Okay, very simple. Then L for element number 2nd, what is the length of element number 2nd? That is 20. What is x? That is 10. So 20 multiplied by 10 is equals to 200. And so in this way you can calculate the Lx. That is the multiplication of length of that particular element into x. That is the distance from y. And that we know. So we can calculate, we can do this multiplication, and we can get, that is Lx. Very simple. So in the same way we can calculate the Ly. So what is Ly? That is L into y, that is distance L, that is length, into distance y. So multiplication of that L into y, so that will give you the Lx. Okay, very simple. Again, multiplication L into y. So we can calculate for all elements. So we can calculate Ly, and also we have calculated Lx. Okay, then do the summation. That is summation Lx. Then do the summation, that is summation L and summation Lx. Do the summation L, calculate the summation L and summation Lx. And so here you can see we have calculated, that is summation L, that is 119.70. Then summation Lx, that is 1421.26, and summation Ly, only you have to do the summation, that is 1197.70. So once you have calculated the summation Lx and summation Ly, then what you are going to do? We are going to calculate the x bar and y bar. So what is x bar? That is summation Lx divided by summation L. That is the total Lx, that is summation Lx divided by summation L. So in the same way we can calculate, that is summation Ly we have calculated. So we can calculate, that is y bar, that is summation Ly divided by summation Lx. So here we have calculated x bar is equals to 11.874, and y bar we have calculated, so that is nothing but the 10. So what is this x bar and y bar? So that is nothing but the center of pressure of this particular component. So that we can mark, that is x bar is nothing but center from, that is the distance from y, and y bar is nothing but the distance from x. And so here you can see, that is the center of pressure lies at this particular distances. that is 11.874 and 10 and 10. So as shown in figure, that is center of pressure is a point about which the summation of shearing forces is symmetrical. The axis of center of pressure R shall pass through the center of pressure when maintained there. Right? So here you can see in the sketch. So here this is what is the point. This is what is the point. That is the center of pressure of this particular component. So definitely the question will arise, why to calculate the center of pressure? So that already I have told at the beginning itself, because because this particular component is unsymmetrical, and as this particular component is unsymmetrical there, so whatever the center of the punch must pass through the center of pressure of this particular component, and if it is not passing through the center of pressure of this particular component, then what will happen? The bending of the punch may be there. And to avoid that, why bending of the punch will be there? Because this particular component is unsymmetrical, and as this particular component is unsymmetrical, the center of pressure must be aligned with the axis of the punch. If it is not aligned with the axis of the punch, then bending of the punch may be there, and to avoid this, the center of pressure line and the axis of punch must be aligned there, so that the bending of the punch will be avoided. Okay, so center of pressure will be calculated. So procedure for calculating the center of pressure will be the same, whatever may be the shape of the component. Okay, so once the center of pressure is calculated, the next thing what you have to calculate, that is you have to draw the scrap strip layout. And the next thing what you have to do, you have to draw the scrap strip layout, that how will be the material, that is the scrap material which is going to be there. Okay, just a minute. Yes, whatever we have discussed, that you understood or not, please comment. And so first of all, center of pressure will be calculated, and then further the numerical can be solved. And so basically in the examination you need not to write each and everything, only you can do the calculation. But here in this particular PDF, for the purpose of understanding, each and every points is written here. Okay, so few students contacted me that they are not getting how to calculate the center of pressure. The other things they have understood, but how to calculate the center of pressure of this particular component, so they are not understanding, and that's why we have conducted this online session. So let me know whether you understood that how to calculate the center of pressure. Please comment in the chat box. Okay, one more doubt is there, that is length of number 4, that is element 4. Okay, we'll go to the element number 4. So which one is the element number 4? This one. This one is the element number 4. So element number 4. So this one is the element number 4. So what will be the length here? So for that particular, what you have to do? You have to join this one like this, and you have to join this one. So what is this one? This one is nothing but the right angle triangle. Very simple. This one is the right angle triangle. So when this one is the right angle triangle, then we can calculate the length of slanting length, that is the slanting length of this element number 4 by using Pythagoras theorem. That is, hypotenuse square is nothing but equals to base square. Hypotenuse square is nothing but equals to base square plus height square. So this one is the base and this one is the height. So and this length is nothing but the hypotenuse. So hypotenuse square is nothing but equals to base square plus height square. So in that way you can calculate the length of element number 4 as well as the length of element number 3rd, and length of element number 4 and the 3rd, so that you can see it is same. Okay, so have you understood this, Tushar? Can you tell me, have you got this? So here any doubt is there, please, and if you are having any doubt, please comment in the chat box so I can repeat the same, because it is very simple calculating the center of pressure. And once the concept is clear, very easily you can calculate the center of pressure, and whatever the shape of the component it may be, the procedure for calculating the center of pressure, so it is going to remain same. So any doubt is there, please? If not, just type understood. So rapidly I will go to the next step. So few students contacted me and they told me that they are facing the difficulty in how to calculate the center of pressure, and other things they are understood. And so rapidly I will go through that also, and then we'll stop. And so if you are interested to have the discussion on any other topic, then also you can comment in the chat box, so that maybe today and maybe in the afternoon or maybe in the evening we can play. Otherwise your exam is scheduled, so definitely you supposed to get, or you should have, or you have to revise whatever you have studied there. So other things, that is you have to draw the scrap strip layout, that is the what should be the scrap or what should be the size of the material, and so that is nothing but the scrap strip layout. So basically it will decide the correct and sufficient stock between the blank and the strip edges. This avoid the weakening of the strip and also the breakage and the misfit. And so for that particular purpose, this is what is the resultant shape of the components which we require. So we have to calculate the distance B, which is same, and we have to calculate again the distance C. Here you can see that is distance C that you have to calculate, and also you have to calculate the thickness of that particular scrap material. Okay, so that we can calculate, that is thickness of the material. T is nothing but equals to 1.80 mm, that is the thickness of the material. So accordingly, from the thickness we can calculate the B by using this particular standard formula. So if thickness is less than 2.5 inch, or when the thickness is greater than or equals to 2.5 inch. Okay, then when we know that when we have calculated the B, so we can calculate the C distance, that is L plus B, that is the lead of the die. Okay, so here you can see in the problem or in the numerical it is given T equals to 1.80 mm. So B is nothing but we can calculate by using the standard formula, that is 1:1/4 multiplied by T, that is 1:1/4 into 1.80, that is 2.25 mm. Again we can calculate the C, that is C is nothing but equals to L plus B. So what is L? That is 30 plus 2.25, and L is given, that is 30 mm. So 30 plus 2.25 is equals to 32.25 mm. So whatever the dimensions which you have calculated in the scrap strip layout, so that is mentioned over here. So this 30 it is given in the numerical, this 20 also it is given in the numerical. So what you have calculated? You have calculated this one, that is B. We have calculated this one, that is C. Okay, so from this you have to calculate, that is the percentage of stock which is going to be used there. So again the standard formula, percentage of stock is nothing but equals to area of the part A divided by the area of the strip which is going to be used there. Okay, so here you can see, that is the area of part A. This one is the part A. This one is nothing but the part A that you can see. So that area of the part A that you have to calculate. So what is area of part A? That is the area of the square plus area of the triangle, and area of this particular square plus the area of this particular triangle, and from that what you have to subtract? You have to subtract the area of the circle. So if you do that, so you can get the area of the part A. So same thing, area of the square plus area of the triangle minus area of the circle. So we can get the area of the part A. So that we have calculated. So it is 421.46 mm square. So area of the strip used, so that can be calculated, that is 32.25, and area of the strip which is used, and area of the strip which is used is nothing but we can say this total distance, that is 30 C distance, that is 32.25 into 24.50, and 32.25 into 24.50. So that is the area of the strip. And area of the strip how it is calculated, and you can see once again this distance, that is C distance, 32.25 into this one width, that is 24.50, and also it is equals to 790.125 mm square. Okay, so percentage of stock which is used, so that can be calculated. So it is 73.22, means 73.22% of material will be utilized. Okay, so 73.22% of stock or the material, so which is used, so that is given in the configuration. Then press tonnage, so that can be calculated. So it is the amount of pressure needed to carry out the required cutting or the forming operation. So press tonnage P can be calculated. So that is nothing but equals to cutting length into shear strength into thickness, that is cutting length, that is the total length, multiplied by tau, that is the shear strength which is given, into thickness, so that is also given there. So total length we have calculated, that is summation L, into tau, that is given, that is 170, into T, that is 1.80. So we have calculated it in Newton, so convert into tons, so it is 3.77 ton. So from the production requirement, a progressive die with a single pass strip is used. So it is 2-station progressive die will be used. So from the working of progressive die, so from 2-station progressive die will be used. So in one station, this particular circle, that is the punch, that is the square, the punching will be done, and in first station punching will be done. So this particular material will be cut, and in second station, so we can see that is this particular shape will be cut there, and this particular shape will be cut there. So first will be the punching die, that is what is called as a piercing die, that is piercing operation will be completed in first station, and in second station you can see, and ये जो रहेगा same sheet will be forwarded there on the second station. So in first station punching operation will be done, means this particular hole will be useful, and in second operation, in second station the blanking operation will be done, means this particular cut material, that is the blank, will be useful there. And so you know the difference between punching and blanking. So in the punching, the material which is cut there, or we can say whatever the hole which is produced there, and that hole will be useful. And in blanking, whatever the material which is cut and it is fall there, it will fall there, so that blank will be useful there. Okay, so in the same way here also you can see, that is in the first station punching will be done, this particular hole will be produced, wherein this particular hole which is produced will be useful, and in second station the blanking operation will be completed. So whatever the blank which is cut, so that blank will be useful there. Okay, so I think you have got this, very simple. So same thing is written here. At first station the hole is pierced, that is punch, the strip will move to the second stopper, a pilot would locate the strip and part will be blanked out. Then reducing cutting pressure. So for reducing the cutting pressure, so in the theory lectures, so if you attended, so for reducing the cutting pressure or for reducing the punch pressure, so two methods we have discussed. First one is nothing but the shearing the punch, and second one is nothing but called as a by staggering the punch. So in the shearing the punch, angle will be given to the punch or the die, and accordingly the total line perimeter or the total perimeter of the punch which is in contact with the sheet when it is cutting there, so that will be reduced. Ultimately the force which is required for cutting the material will be reduced. And so that is nothing but called as a shearing of the punch or the shearing of the die. So that is the first method by using which the force which is required for cutting the material will be reduced. But here you can see progressive die is used, and that's why on the progressive die the second method will be used. So that is nothing but called as a staggering of the punch, and here it is mentioned that you can see that is the cutting force can be reduced to smooth out the impact load. So it is done by staggering the punch. That is in this way the punch will be staggered there. And so punching will be done there on the first station and blanking operation will be done there on the second station. Okay, so I think you might have gone through this particular PDF. This already I have provided to you, and I think you understood this. And let me know in the chat box so whether you have understood this or not. And please comment in the chat box. So next thing, that is punch and die clearance. So again the standard formulas are there. Average clearance per side, that is 5% of material thickness. So from that you can calculate the average clearance per side. And so 5% of material thickness, so it is recommended for the normal blanking and piercing operation. Then piercing punch diameter, then piercing die diameter, so that can be calculated. Scrap strip layout we know, so we can draw the die set like this, that is in the first station. So this is scrap material, you can see, whereas this punched hole will be the useful one, and here in the second station you can see this is useful, that is blank is useful. Okay, then striper force. And so basically whatever this one, so whatever this is there, so it is nothing but the striper. Okay, so that you can see. So striper must exert the pressure so that strip will be kept on the die. Otherwise what will happen, when the punch is exerting the pressure, so because of that punch pressure, the strip may be pulled there inside the opening of the die, and because of that the wrinkles can be formed. So to avoid this, on the strip the striper should exert the pressure, should exert the force, and what that particular force, so that will be calculated, that is the striper force, that is the force required for the striping. So it is 20% of blanking force. So again it is standard formula, so from that you can calculate, and so it is equals to 0.6 tons. So required tons we can tonnage required, so it is 3.60. so from that you can select the capacity on the higher side, that is 5 tons capacity. So again die block calculation we can do, that is the die thickness and all, so that can be calculated there. So for the die thickness, so again you can see this is what is the standard which is given, that is the blanking perimeter. So if it is up to 3 inch, so this is the die block thickness. So if it is from 3 to 10 inch, then this is the die block thickness, that is 1 inch. So if it is greater than 10 inch, then you can see that is the die block thickness, so it is 1.25 inch. And so these standards we have to use, and accordingly accordingly you can select, that is in the given numerical, that is the blank perimeter will be nothing but equals to, it is given, that is 119.75 mm, that we have calculated, and accordingly we can see that is 5 inch will be the die block thickness. And that is the die block thickness will be nothing but equals to not 5 inch, and here we can see blanking perimeter is 5 inch, that is 119.7 mm. If it is converted into inch, so it is 5 inch. So from that we can say it is in the range, that is 3 to 10 inch. So it is in the range 3 to 10 inch. So you can select the die block thickness, so will be nothing but equals to 1 inch. Okay. So 1 inch. So that 1 inch can be converted into mm. That is 25.4 inch. Okay. Again you can see the margin can be calculated. So there should be the minimum of 1.25 inch margin around the die opening, that is expected. So 1.25 inch, so that can be converted into mm, so it may be around 30 mm. So again the next point, that is the straight or the land, so will be nothing but equals to the thickness of the material, maximum will be nothing but equals to the thickness of the material. So thickness of the material is nothing but, it is given, that is 1.80 mm, so we can consider approximately equals to 3 mm. Again we can calculate the angular clearance to avoid the jamming of the blank part. So for clamping the die blocks to the die holder, die block area must be greater than 10 square inch. If it is greater than 10 square inch, then we can say use this 2 cap screw or use this 2 dowels, and to avoid the clamping of the die block to die holders. And so this is again standard formula, standards that you can use. So use of pilot results in production of accurate parts. So pilot should be made of good tool steel of sufficient toughness and the hardness. That is what is, we can say Rockwell hardness, that is 60. So again the striper that is given, and we can say like this, the spring loaded striper, so that can be used there, so that it will keep the strap in a particular position, in a proper position, so that the wrinkles on the components, so that can be avoided. So this is what is from my side. So if any doubt is there, please ask, please comment in the chat box. So if you understood everything, if you are, no doubt if it is there, then please comment. So that we can stop today. You can also comment that any another bit you needs to explain, any another numericals you are feeling that should be discussed again, so that also we can discuss. If not, you can do the revise. So all the best for your examination. So please comment in the chat box whether we should stop today. So if yes, please comment, and so we'll stop here today. Thank you everyone. Thank you for joining. Thank you. So I will stop here.